Hi everyone, it's Kieran here from Team Chicken. Another release of DevKit due today, so I thought I'd do the usual demo of a few of the new features. So as you can see here, this is something actually just added last minute, but it looks pretty cool. It's a 3D vector display plugin and device. Now, I think someone on Reddit came up with a suggestion for this, and Notch kind of liked it, said he might implement it. Purely prospective again, but pretty cool idea and something to play with while we're waiting. Obviously, there's been a bit of an information void for the game recently, so just trying to come up with something fun to play with. So this is a plugin for DevKit, as I mentioned, and it is implemented as a hardware device within the system. So we'll go through a few of these details. This is a quick test program I knocked up, drawing couple of faces of a cube and a line, and then this sort of bouncing dot. So let's just take a quick look at the code. Incidentally, it runs sort of by default in this as a second screen at low resolution. You can open up a bigger one. So this is a plugin. As usual, it's got the documentation. Take a quick look. As before, just a little pop-up window, kind of handy. So as with other devices, you fire up the interrupt for the device in question, pass in the command in the A parameter, the A register. So you can turn it off, you can output a test pattern, you can set it to user input mode, which means that these other commands then work. These commands work, which is where you can control the XYZ coordinates for the flare point, which is just the point, the target of the display. It make more sense in a mo. So if I just show you here, this is the startup bit. If I set that to set mode none, off I guess, then you get nothing. If you set it to test, you get the test cube, and there's a bit of noise there, and that actually relates to something else used in the program, which is the noise level. So it's kind of a bit jittery there, and that's kind of a feature whereby if you wanted to show something is not very accurate or make something look a bit bigger, you can turn up the noise level. What's a good way of demoing that? If I put a loop here, set PC hang. So there's no noise. Noise level is set to 0, and the noise level is a little error put into each coordinate that's specified. So you can ramp it up to maximum. Looks a bit like that. So it just looks a bit crazy. Perhaps I was thinking as something comes into view or out of view on some kind of HUD or something, it might be a bit noisier. Halfway, and off we've already seen. So that's actually used to effect in the test program. That's not quite right. Oh, the hang. Incidentally, yeah, that's if you're not setting the coordinate, it just sort of sticks there at one offset. This rotation is an auto rotate feature you can read a bit more about in here. You can set the speed of rotation, degrees per second, and that kind of thing. So if we get rid of that loop, basically what we're doing here, we're a little main loop that updates the position and velocity of a ball, actually based on something I saw way back in a Commodore 64 manual, in 2D of course. But we're drawing this with a higher noise level, so it looks a bit bigger. It looks almost a bit round. It's not actually round. It adds random value to X, Y, and Z coordinates, so it would be a cube it's approximating. Anyway, and these lines are drawn without any noise. So that's that effect. Yep, pretty cool. Hoping to see someone do something with that. This is obviously very straightforward test program. Let me know how you get on with that. So other new stuff in DevKit, there's segments. It's actually obviously been a couple of weeks, so I'd like to apologise for the delay there. There have been quite a few things going on. I wanted to make sure that this release was a pretty solid one. So segments, you can refer to different, or you can create different segments of code, which may be familiar to some and not to others. But you can, by default, let's say the segment is default, which works just as the previous versions, and with most assemblers, your code gets compiled and all the output words get dumped in the output just in order. So say you wanted to put all of your data at the end of the file so that you don't have to jump over it, or it's all in one place. You could use segment data. Now by default there's a data segment which comes after code, so if you put segment data and then define something like that, that will appear after the code segment. And what this does, obviously that outputs or creates a word in the data segment, and then this switches back to code. So this is actually the first instruction. So if I step into it, it obviously starts there, and anything referring to vector display will actually refer to something in the data segment. It's handy especially when doing things like if you wanted the code here obviously has to refer to some things, you can define it just before. You can actually do a line of code and then a line of data and so on, and yeah, so you can just put it before there. You can even define or refer to segments in macros. So if you wanted a print macro, quick test, you could do something like something like that. So wherever you called print like that, it would pass that parameter in, store that in the data segment inline, and do the code. So you can do it inline like that, which is very handy. There's other stuff with segments. You can give it you can create a segment with any name, and there's priorities and so on. If you check out the online manual for more information about that one. Okay, so one of the main features is the introduction of different project types, which are implemented by different plugins. So it's easy to create your own or extend the DevKit. The main project type is code. It references, or rather, it creates code output. It deals with code files, compiles them into a single output file, and it can reference other code projects. So if we take a quick look at this, we've now got project properties, and you can see there's some options for that. So you can say compile a particular file first, which sets it as an entry point. It says if not using segments, because you can get round this using segments. And there's a little tick box here for generate self-relocating code, which is quite a cool one. That helps with disk projects and applications in general. If you tick that, then it will generate some code at the beginning of the output in a segment, in fact, called reloc code, which will mean that the code will run correctly and reference all of its relative offsets, no matter where it's loaded in memory. So most programs expect to start at 0000, but of course if they're loaded from disk, there's probably an operating system at 0, so it'll be loaded somewhere else. And if I step into this, we should see some of that code. Yeah, so it's jumped straight to disassembly because there's no source code for that, but it grabs the current program counter, checks to see if it needs to relocate. In this case it doesn't, so it jumps straight to the program here. But if it was loaded at an offset, it would, using some data tables, it would change any of the instructions which refer to something at a fixed location in memory, and it will add the offset that it detected it was loaded at, which is very handy. So but you usually needn't worry about that. You can leave it turned on. It just a bit of extra code at the beginning, but it will run fine. And there's output formats. You can check whether you want binary or hex output. There should be more as well. Planning to do a plain assembly output as well, but not in this version. So code projects. Yeah, I'll demonstrate references just quickly. If we create another project, let's say we want to call it vector display, and we want to chuck some code in there, something like what can we put in there? I know, we'll just put some definitions, say. That should work just fine. So it's almost like a library. We can right click on references and add a reference to another code project, and builds just fine, runs just fine. So usually you'd put obviously different methods, subroutines or something else useful in there, but yeah, it's different from the previous DevKit whereby the solution was built and all of the projects were always built into the output of the solution. Now, if you wanted, you could have multiple code projects, each producing their own output. You can share one project of code between different outputs and so on, and you can see it's easy to build up more complex code. If I remove that, obviously it's saying it can't find something there. If we add it back in, it works just fine, so you can see sort of drop in whole chunks of code. Okay, so there's also solution properties. Kind of makes sense because you can now have multiple projects built with their own outputs. You can pick which project you want to start. So it wouldn't be very useful to pick vector display because it doesn't generate any code. In fact, it should give a fault. Yeah, but the first instruction, so that's no good. So if we go vector sample 1, works fine. Some more options. You can run a binary file directly. You can say don't start anything, so if you hit F5 it gives you a bit of a warning message. No solution, no project, and you can optionally set the startup speed of the processor. Obviously this to be padded out as more features need it. Okay, well, one of the other types of new project is a disk project, which is pretty good. It's something I discussed in a previous video, this disk builder idea. So I'll open this project types test. You can see we've got code projects, we've got disk projects, and a test project. Test is obviously another new one, so I'll go over that in a bit. But disk projects. So the idea of a code project is it produces output in the form of binary or hex, and it will be loaded into the emulator or referred to in another project. A disk project its goal is to build a disk file, so a disk image. So any files you add here are compiled on their own, and the output of that is then put into a disk. And the way that it's built up is done through a file system format, and that's again plugin based. At the moment there's only this structureless one. In the future there'd be something for FAT or FAT16 or some other smaller file system. So there's an option there, compressed disk image. There's another option here, you can have it automatically loaded into a drive after the build. But most importantly, I guess, under the files tab here of properties, you can see all the files that are in the project, and you get to pick how they should be put on the disk. So there are a few options. You can see there's two here. This codeproj.bin is the output of this first project. It will build the project first if it detects that you're using the output in a disk project, so it will build it and then build the disk. And that's actually set to file system, which means it will be placed in an automatic location as dictated by the file format you're using, the file system you're using. The other one here is set to sector 0, and the three options at the moment are file system, sector and offset. So you could have something at the first sector in the disk, which is sector 0, or the second one, which is sector 1, or you could say at a specific byte offset. At the moment this structureless file system simply puts anything with a specified offset or sector onto the disk, and then writes any other files using file system just in order after that. So it's sort of a plain dumped disk, which may not be too useful, but there aren't many established or any established file systems out there at the moment. Okay, compilation. Basically, as I say, for disk projects, each file is compiled on its own, and then the output of that is processed into the disk. So you can, for example, here have a boot 10c. I'll just switch this back in a second. But you could have a source file which is compiled and then placed, as this one is, as the boot sector. And then you can refer to another file and have that, so codeproj.bin, and you could have that sitting somewhere else on the disk. And because it's a binary file, it's actually handled by this binary resource, so it'll just be included as is. So what I've done here, actually as a test previously, is change the build action of boot.10c. It's obviously a .10c assembler file, but it's the build action is new here, and it says treat it as a resource file. So actually the source code would be dumped to the boot sector, which isn't great. So if we use this drop down, we can change it to an assembly file. If I double click that, you can see this is just some simple tests. So if I hit F6 to build that, obviously it works just fine. If we scroll down, yeah, build succeeded. We've got a little sneak peek there of some unit tests passing, but if we oh yes, we had the option here to automatically load the disk, so if we quickly check that that works, configure disks, yep, it loaded disk build. In fact, if I eject it, rebuild, you can see it's automatically loaded that disk, which is great because we've got the solution here. For example, if you had something proper going, you could have it load your operating system or a ROM or something like that by default, and also when the build starts you'll have the disk in the drive, so you could simulate a ROM starting up and then an operating system loading or an application loading or something like that, which is quite cool. So let's have a look at perhaps test projects, I think. So test projects, I'll load up this other sample, unit tests. Test project is different from code in a disk project in that it doesn't actually produce any output file on disk. You can add references to code projects. In disk projects you can't add any references because it doesn't make sense, but on a test project you can reference a code project. So for example here, this is referencing this code project here. Alright, and the way a test project works is each file is built, compiled using the appropriate plugin handler, using the references there. So simple ALU here is compiled and using it's also compiled in conjunction with any references, so is division and so on. That's built when you hit the build key, which is F6, and then immediately after that it's loaded into a separate emulator which will run the code in question and wait for a signal which is done through a debugger device to say the unit test passed or the unit test failed, and that's handled again with a plugin. And here it is, some documentation, very straightforward. In fact, at the moment this isn't fully implemented. There's only 4 and 5 used, and they're only used when running unit tests, so the intention is obviously to get all of this up to scratch, but that's not there yet. So when you build, it'll run the unit test. It'll actually run up to 1,000,000 cycles. If it hasn't had any kind of signal after 1,000,000 cycles, then it will say it's failed. Incidentally, that takes obviously no time at all, well under a small part of a second. And if it gets a pass, which is signalled like this, then it's a pass. If it gets a fail, then it's a fail instantly. And there's this new type of file, .10c test, which has some support code so that it's easy to write unit tests. If I give an example, perhaps we'll test that 1 + 1 = 2. So you can just use 10c or in fact any type of file. There's even a C one here which I'll show you in a mo. But if we pick 10c test and we'll say check basic logic, so you get this sort of placeholder code. Some code here in the boot segment which runs before the code segment by default. Again, you can read more about that on the manual page. It tries to detect the debugger device. If it's not found, it says there's no device, and if it is found, or when it's finished that, it'll jump to the unit test. So basically it's as simple as set A 1, set B 1, add A and B. If A is different from 2, fail. Now if I hit F6, it will build this and it will run all these unit tests, and it indicates the results down here in the build output, and also as a little tick or cross in the project there. So you saw those ticks appear. That's all worked just fine. And it's obviously fairly quick, 0.3 seconds, and that's including invoking the external C compiler there. If I change this to say 3, we get the nice little red cross. So, and because it can reference external code, it's most likely that you'll have a load of application logic in an external project, and then you can reference that in your main code project and also in the unit tests, and it's obviously a nice way of getting some little clear indicator as to whether you've got any bugs in your code. And developers familiar with unit tests will instantly see the appeal and the benefits you can get there. Okay, let's take another look at the C here, the C file. So the guys DCPU16 toolchain have been doing loads of work on their C compiler and their build system. Much improved since the last version of DevKit. And I figured I'd update the version and also see if I could get unit tests running, and that is actually exceedingly straightforward. So I'll open this. You can see this is fairly appealing, especially compared to all the assembly we've been seeing. Unit test in C has a main method. It initializes a debugger, which actually calls to an external assembly routine, and then calls test pass, which does what we saw in the other place there. Now, these are kind of support routines. The debugger device, the symbol there, that's not defined anywhere in here. And in fact, what I've built is a separate little code project library called C studlib, which is like a standard library, but it's really cut down. So if we take a look, there's the bootstrap disassembly file from the DCPU toolchain project, which is something that you always need to include when you're building some high-level language code. It has helper methods for dealing with the stack and some setup code and so on. So I've very simply taken out some directives, added a couple of other directives to make it work with DevKit. It's just a couple of lines really, and in this case this is the no screen version, so it doesn't initialize the screen. Currently unit tests run in an emulator with only one attached device, which is the debugger. So if you try and initialize the screen, it simply won't work. So there's this no screen version for that purpose. So the other thing was to enable things like debugger device, unit test pass, and all these detect debugger. Rather than do that in C, I put those routines in the referenced project in unit test bootstrap.10c test, which is largely based on that template you get when you're creating a 10c test file. So the differences are detect debugger. I'm not entirely familiar with the internals of how the C calling convention works, so simply I save any registers that are to change on the stack and then pop them back so I don't interfere with anything. That's pretty much it. Detect debugger pushes everything to the stack, does what we want, and then pops it again. Because that's referenced by this project, we can refer to that and all these defines in the C code. So obviously that looks pretty great. And we can demonstrate this. If 1 + 1 equals 2, equals 2, then pass, and if we fall through, it'll fail. F6, that's obviously got a tick. But if 1 + 1 equals 3, F6, you get the cross. So again, very nice and powerful. What I wanted to do next was show you creating a C program from scratch, just because it's not quite as straightforward as create the solution, create the project, create the file. You need to refer to that bootstrap file, but in fact I prepared one just before, so we'll use that C demo. Very straightforward, to be honest, just not quite as straightforward as the regular assembly. So you can create a C file, you can put your code in there. This is very simple. We've got a pointer to the video memory, a main method which calls print with a message, and then this writes the message to the screen with a standard white on black formatting. The only thing is, if I exclude this there, if I try and build that, I'll get this error here, and that means we need to refer to the bootstrap. In fact, that's not quite the right error. I'm going to fix that before the release in a moment, but it should say unable to resolve symbol. If we reference, basically to get this going, we need to add that bootstrap code. So we add existing file, navigate to the plugin folder for DCPU toolchain, and there are these two options: bootstrap no screen for one that doesn't initialize the screen, and bootstrap regular has it with the screen. So we'll reference that one, and when we build it, it works fine. So if I run that, we've got our output. So yeah, that's a C program that's working fine. It no longer has the stack issues. You should be able to, if I in fact set a breakpoint, we should be able to step through it again. Because there are so many instructions for each line of C code, assembly instructions at the moment, it sort of takes quite a while. If I hold down F10 here, yeah, we can kind of see that that's printing it out, and obviously breakpoints do work and so on. There. Hello world. Great. So there's our C program. So all you've got to remember about that is just adding the bootstrap file, which you can find in the installation folder under plugins DCPU toolchain. So we've got a vector display, we've got segments, we've got code projects, test projects, disk projects, we've got unit tests, we've got the C language working a lot better. There's a new file format in the toolchain, dobj16 and dlib16, which is the same format, but I think that indicates the intended use for libraries, and I'm trying to find out a bit more information about that. So for example, you can add a reference to a particular compiled library, and perhaps we could even have the code projects optionally output that. That shouldn't be too difficult once we get the details of the file format, so that'll be good as well. So hopefully you can see it's all coming together. Hoping to release a bit more frequently, and hoping to get a few more cool features like the vector screen. Again, it's working in a bit of a vacuum at the moment without much information about new features, so looking forward to the next round of that with Notch. Okay, so have fun, have a good week, and I'll see you